All right, so let's continue with our day 2. Yesterday was day 1, and today we're going to day 2. So let's label this day 1 of MongoDB administration. We discussed or introduced what replication is in MongoDB in simple terms that everyone can understand. But before we move to day 2, let's see how many views we got from our day 1 video. I'll go to YouTube real quick. So we got close to 43k views, but the problem is K is silent. Let's confirm that. Let's confirm that right here. So yesterday, I believe we got around 43k views or 37k views, but the K is silent here. YouTube has a problem with the styling of zeros, So what they did they didn't show the 3 zeros alongside my 43k views. So what we're going to do, let me just switch accounts really quick because I have 2 accounts. But apparently I think 43k views is a lot. That's some massive support from the community, because we need to upskill on MongoDB. We need to learn a lot of things. So let's see. I'll go to my channel. Let's see what we have. Okay, view my channel here. Osego codes, dream the code the dream. So we come to videos here. Let's see what we have. Apparently, YouTube has a styling problem. They have problems with the zeros. They have problems with the Ks. So this should be 43k. But anyways, that is a massive win. 43 views in a single day is massive. Thank you to the community supporting this initiative. So back to day 2. So day 2, let's do something different. We're moving to something else. I'll undo that and then come here and go back to the cursor so that I can scroll this way. So today is day 2. Let's just have that here. Day 2 of MongoDB upskilling program. Upskilling. All right. Day 2. But before we start day 2, let me talk about something. Let's Google something here. What we want to Google is very relatable to what happens in MongoDB. Now, what we're going to Google is what happens when a president dies. Exactly. Let's see what we have. Now, if the president of the United States dies, the vice president immediately becomes president, as outlined in the US Constitution and 25th Amendment. If the vice president can't serve the Speaker of the House, then the President pro tempore of the Senate and the cabinet members, in order of department creation, take over until a new president is elected or situation resolves. Right. Now, in Kenya, the deputy president assumes office for the remaining term, or if unavailable, the Speaker of National Assembly acts as the president, with a new election held within 60 days. Now, I'm heavy on 60 days here. What we want to do, let's copy this statement here in Kenya. I'm interested in this one here. So we'll copy this and have it on our canvas here. So let me come here and just paste it here. Exactly. So here's the point. In Kenya, the deputy president assumes office for the remaining term, or if unavailable, the Speaker of the National Assembly acts as the president, with a new election held within 60 days. I want us to highlight some important points here. 60 days. And also let's highlight new election happens, right? Then deputy president assumes office. This one here, not really important, but we look at it. Now, I'll change this back to transparent. Now, what happens? Now, if the president dies, then an election will happen after 60 days. This is the same thing that happens with MongoDB, right? With MongoDB. Remember yesterday, we mentioned something about election happening right here. We said, if the primary is down, the primary node is down, then election will happen so that we elect a new primary. In Kenya, it is done after 60 days. But how about in MongoDB? How long does it take for an election to happen? Right? Yesterday, we also talked about something called heartbeats. So heartbeats, a human heartbeat can happen every second, right? Or after an interval. After every interval, a heartbeat happens, right? Like this, like heartbeat happens, heartbeat happens, heartbeat happens at regular intervals. The same thing is the same thing Mongo 2 is also doing. Heartbeat at every 1 second or 2 seconds or 2 seconds, 2 seconds, 2 seconds, sending a heartbeat signal to the primary. All right. Now, MongoDB sends these heartbeats after every 2 seconds, right? Now, it sends it after 2 seconds. So let's have that here. Let's have that noted here. Heartbeat is sent after every 2 seconds, right? So this means after every 2 seconds, we'll have the secondary nodes sending heartbeats to other nodes. Why? To confirm if they're healthy. Now, we also have a timeout for heartbeat timeout, right? These are two terms which are related. So we'll come here and then we have what we call heartbeat timeout. You know what happens when you call someone a heartbeat? When you think about them, your heart pumps like poop, 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 right? Now, it's the same thing that with MongoDB. MongoDB, they're like a family here. So they have to like think of each other each and every time to ensure that they are all okay by sending heartbeats. Every time I think about you, my heart beats. You're my heartbeat. So it sends that signals here at every 2 seconds. Now there's a timeout of 10 milliseconds. So this means we have a timeout of 10 milliseconds. Let me just show you here. So the heartbeat timeout is 10 milliseconds. 10 milliseconds. Not 10 milliseconds, but 10 seconds, I mean. 10 seconds. Of course, in MongoDB, these parameters are given in terms of milliseconds. So you will find the value to be 2000 milliseconds. And for the timeout, it will be 10,000 milliseconds. Right? This will make sense. So this means if I send a heartbeat 5 times and there's no response, then what will be triggered? An election. Remember, 10,000 divided by 2 is 5. So it means any secondary node has to send a heartbeat at most 5 times with a failure. If it does that 5 times and still fails, then the timeout is reached, like it's maxed out. So then what happens? Election is triggered. It's triggered. That is what happens here. Let me just have a drawing here to show what will happen. If it times out, election is triggered. So election is triggered. So now we have only 2 remaining nodes. Only 2 that have to vote. We have 2 remaining nodes that have to vote. That is maybe Mongo 2 and Mongo 3. But I'll just draw the nodes right here again. So we have, no need of drawing actually. I'll just explain this here. Now election is going to happen between Mongo 3 and Mongo 2. Now the main question is, which is the main point of discussion today, is how do we elect a new leader so that the rest can be followers? How do we elect a new leader? Or how is a new leader elected? That is the question. How is a new leader elected? Right? Once we ask ourselves that question, it will help us in designing a very resilient MongoDB deployment. Now, I have an instance here, MongoDB 1 and MongoDB 2. Or this should be actually MongoDB 2, Mongo 2, and then this other one should be Mongo 3, because they are the remaining secondaries, of which one has to be a primary. Now, during the installation of a replica set, the configurations that we put in place, one is what we call the priority of a node. Priority of a node. Number 2 is the number of votes. Is it a voting member? All right. So Mongo 2 will have its own properties, and then Mongo 3 will also have its own properties. So we need to like duplicate this. Let me see if we can duplicate. Good. So we have this here. Now priority is the higher the priority, the more likely a node will become the new primary. The lower the priority, the less likely a node will become the new primary. And priority numbers range from 0 to 1000. Okay, so let's have a priority range here. Priority ranges from 0 to 1000. Okay, that's the numbers of priority, any figure in between here. Now, in most cases, you'll find that priority of Mongo 2 and Mongo 3 are different. How? You will realize that either Mongo 2 has a priority of 1, and then Mongo 3 has a priority of 2. Then Mongo 2 also has a vote, 1 vote. It's a voting member, 1 vote. And then Mongo 3 also has 1 vote, which means they are eligible to vote, right? So we come here and we also assign Mongo 3 1 vote. Now, when an election is triggered, the first condition that is checked, which node has the higher priority? Then we see that it's node 2, right? Node 3, Mongo 3. Mongo 3 has priority of 2. This will automatically become the new primary because of the priority number 2. So that is point number 1. How is a new leader elected? So 1, let's have those points here. 1, based on priority. I think that's right. Right. So then, because Mongo 3 has priority of 2, that will now be the new primary. Another factor to consider during an election is amongst these nodes, which one has the most recent data? Remember how this happens. There's something called latency. Okay? There's something called latency. So you realize that maybe Mongo 3 is in Ireland. Mongo 2 is in South Africa. South Africa. And then our primary node, which was the Mongo 1 yesterday, this is in Kenya. Now, between South Africa and Ireland, which one is in close proximity to Kenya? Of course, South Africa, right? So this means that even if replication is happening at the same time, then data is copied faster to South Africa than to Ireland. This can delay by 2 seconds or 3 seconds or even 4 seconds because it's another region. But South Africa is more close to Kenya compared to Ireland. So in a case where we assume that both nodes have same priority, then what Mongo will look for next is what we call the most recent data. Now, either Mongo 2, which is in South Africa, must be having the most recent data. Now that will become the new primary. Suppose priorities are the same. So what we look at here again is the node with the most recent data, right? That brings us to point number 2. Node with the most recent data. Point number 3. What do we consider again when performing an election? MongoDB is funny. Sometimes we can have another node. I'll call it node 4. I'll call it node 4. node 4. You see, I haven't named it Mongo 3. I've just called it node 4. Now, node 4 here, it has a MongoDB installation, but it has the MongoDB installation, but it doesn't have any data inside there. It's simply there to vote. All right. So you can guess what is the configuration that you're going to have in terms of priority and voting member. What we expect to have is this. Let me duplicate this once again. What we expect to have is the priority will be 0. Remember, this has no data. It's simply what we call an arbiter. Let me name it here. It's an arbiter. No data. It's just there to ensure that we have the majority or to help during voting, right? So the priority here should be 0. Ask me why it should be 0. It should be 0 because at no point we should ever elect an arbiter that has no data as the new primary. That is a terrible decision. So it has to be 0. And if the priority of a Mongo node is 0, then it can never become a primary. Then since it's a voting member, it must just have 1 vote. That is 1 vote. So in that case, suppose we only had 2 remaining nodes, that is Mongo 3 and arbiter, assuming Mongo 2 is also down, then at any given point, Mongo 3 will become the new primary because arbiter is only there to confirm the majority and to vote. But it has no data. The priority is 0, but it has 1 vote. It's simply there to confirm majority. So that brings us to the next point of what to consider during election. That is what we call data bearing node. So it has to be a data bearing node, or what we call non-arbiter. Now, this is what typically happens during an election. Once the primary is down, remember MongoDB sends heartbeats after every 2 seconds, and there's the heartbeat timeout, which is 10 seconds or 10,000 milliseconds. So which means a node can send a heartbeat 5 times maximum, and if it fails to get a signal from the node where it's sending the heartbeats, then there will be a timeout. Once you have a timeout, MongoDB automatically confirms an election. An election, as opposed to Kenya where we do after 60 days when the president dies, in a Mongo deployment, it happens within 10 seconds. We'll be having a new primary. How's the new primary elected? New primary is elected by considering the following factors. The priority. That is, the higher the priority, the more likely that node will become a new primary. The lower the priority, less likely that node will become the new primary. Number 2 is to consider the node with the most recent data. Depending on the locations where your nodes are hosted, an example I gave here was assuming our primary was in Kenya, we have a secondary in South Africa and another one in Ireland. We are sure that South Africa will have the most recent data because of the small latency here compared to the high latency that we have in Ireland. So also based on that, MongoDB will decide on which data bearing node has the most recent data. And then another condition is that any new primary must be a data bearing node, not an arbiter. Arbiter has no data, but he's only there to confirm majority. So the priority is 0, and in a Mongo, if a priority is 0, that can never become a primary. But remember, it still has a vote, so that it can participate in elections when we only have like 2, or we have only one node having data, and then arbiter there having no data. So it will confirm the other node with data as the new primary. That is basically how election is triggered and conducted in a Mongo environment. Thank you for watching the video till the end, guys. See you in the upcoming video. Osego Codes signing out.